Bismillah. Today, inshallah, we're going to start chapter 4. We'll talk about transport layer. Transport layer is the first layer that starts to deal with networking issues. So for us, the application was just a way for us to represent the information in a specific way and then address the end-to-end communication using either client server or peer-to-peer paradigms. So transport is layer 4 in the reference model, okay, and the most common protocols in transport layer are TCP and UDP, Transport Control Protocol, and UDP, which we will talk about them. So layer 4 data stream is a logical connection between two endpoints. So as we said before, we have like a host and another host. Those two hosts could be client server or peer-to-peer. Each of these hosts, they run application. We call this application an endpoint, and the transport layer provides some kind of a logical connection between those two endpoints. Okay, so by an endpoint we mean an application that runs and represents the information in a specific way, and the transport layer provides this end-to-end communication between the two endpoints. So that's why we call it a logical connection. It's not physical connection in the sense that it's a wire, because the wire provides the communication between multiple hosts and multiple applications and stuff. But this is logical because it's only it's not actually physical connection. So this service is sometimes called end-to-end service, and the transport layer provides two important. Of course, there are tons of other protocols in the transport layer, but these are the most two common protocols in the transport layer: the data control protocol and the user datagram protocol. Of course, we'll talk about these two protocols in detail. So when the application produces the information, either using HTTP, Telnet, FTP, whatever, this data will be represented or put in another envelope using the encapsulation, and then the transport layer provides this header. So this header can be either UDP header or TCP header. This is how the two headers look like. So the UDP header is much simpler, as we can all see, and we'll see what is good and bad about this. Okay, so these two headers will be represented using the transport layer header, which will then be pushed down in the. So the transport layer, the first thing it does is that it provides the segmentation. So the application sends you the content in a form of a web page or maybe video file, audio file, things like that. So this is the information that we need to communicate. The transport layer takes this first of all, and it divides it into segments, because you cannot, as we said before, you cannot send the whole file as one unit. You cannot do that. So you have to segment it. You call it, you have to segment it. So that's why in transport layer protocol we always talk about segments. So transport layer protocol deals with a set of segments. Okay. So the primary responsibilities of the transport layer protocol is just to manage the communication between the individual applications end to end, and then it segments the data and provides some kind of a management to these segments. So as we said before, when we divide into segments and we have to do multiplexing and demultiplexing, then what we need to do is that we need to put some sequence numbers into these segments in order to know the order of these segments and whether or not we have received all the segments. And of course, if we have to do segmentation, then we have to do reassembly. So this is the reverse operation. So at the receiver side, we just receive all the segments and then we concatenate all these segments together to get the actual data. And of course, in order to provide endpoint to endpoint communication, we have to identify the endpoint. Because as we said, when the segment arrives to the host needs to know which application I should send it to, right? So the host will have to get the application identifier from the segment in order to put it to the right application buffer, right? Because the host will be running multiple applications at the same time. So the transport layer provides these two protocols which deals with segments. So this is an example of this. So you have a web content. This web content is just, for us, any content is just a unit of information. So the first thing we do is that we have to divide this into segments. For each segment, we add the transport layer header, either TCP header or UDP header, and we'll talk about the difference between the two. And then we send it to the other side. When we send it to the host needs to read something from this header to know which application it should send it to, whether I should send it to an HTTP client or server, or I should send it to a telnet, or I should send it to whatever. Okay. And by this we call this a multiplexing and demultiplexing. Multiplexing and demultiplexing. So using this transport layer header, the transport layer may actually provide different types of services or quality of services. For example, TCP provides, in brief, TCP provides all services and as one package. Take it or leave it. Provides everything. Provides reliability. Provides error checking. Provides flow control. Provides congestion control. Order delivery. Okay? So it provides all of this. UDP does not provide any of this. This is the simplest way. So if that requires or provides reliable, this provides unreliable communication. Okay? So the only thing that UDP actually gives you is the segmentation. It actually divides the information into segments, and on the other side, it collects all these segments to reassemble it for you. However, it does not guarantee that these segments will be delivered properly on the other side. It does not guarantee a specific order of the delivery. It does not guarantee that when you receive these segments will not be corrupted. It doesn't guarantee any of this. So assuming that everything is perfect, assuming that there is no loss on the line, assuming that the network is perfect, and everything arrives in order, then UDP can work fine. Okay? But if there is any possibility of error, especially in مثلا wireless or something like this, then UDP might be a problem. Okay? So
then why there is such
we'll talk about it. Yeah, we'll talk about this. The question now is, of course, why bother? Why having any UDP protocol? In fact, many applications, as you can see, they use UDP. They still use UDP, okay? And here, applications that require some kind of reliability, they use TCP. However, reliability comes with a cost. Reliability comes with a cost. And sometimes having no reliability is actually better. Okay, that's what we need to talk about. So what do we mean by reliability? Reliability means that if the segment is sent, I have to guarantee that it reaches it on the other side, which means that the other side has to tell me whether it received it correctly or not. Because if it doesn't, I'm going to have to send it again. And if it doesn't in the second time, I'm going to have to send it again. Forever. I'm going to have to make sure that it arrives to the other side no matter what. Even if I spend as long time as I need. That's why I said it. Sometimes it's costly. Okay? Error checking is slightly different. Error checking is that it does arrive on the other side. Okay? But the data inside it is corrupted somehow. So if the data is corrupted, I have to ask myself, well, can I actually recover the data that is corrupted without having to ask the transmitter to resend it? In some cases, yes. In some cases, that's actually possible. But the first step, I have to make sure that it's simply, you send a frame. You send a frame like 1 0 1 0 1 0 1 1 1, something like that. Okay? So this frame, by the time it arrives to the receiver, this one becomes 0. So for us, this is not the data that we send. First of all, how does this happen? How does this happen?
Wrong signals or...
Yeah, that's a perfect answer, really. Because what happens is that this data will be transferred as analog signals eventually from the physical layer point of view, right? So these analog signals might have noise, you know, they might have attenuation, they might have whatever phenomenon, okay? So in that case, when it arrives on the other side, I have to decode the actual binary data from this signal. So this data actually, on the physical line, it would be something like this. Due to noise, I have to do the reverse operation and get, but actually due to the noise that gets, that affect the signal, this data might be decoded in error, okay? So there might be 1 or 2 bits difference. And by changes, we mean that when we know that the change happens in this bit, we know that we just need to toggle because we have two states, right? Either 1 or 0. So so based on that, the frame arrives in error. So the question now is that how can I detect that this error, that there is some kind of an error that happens? Well, the simplest way is just to add some bits in here, okay, which provide some kind of a mathematical combination of these bits and stuff, so that if this content changes, these bits will tell me whether there is an error or not. This is what we call error checking. Okay, so that's what we mean by error checking. So TCP provides error checking. Well, error checking sometimes is, of course, it is important. Actually, in fact, UDP, in most of the cases, it does provide error checking as well. Because we cannot afford sending anything that's corrupted to the application. We cannot do that unless we make sure that the application itself has some error checking. Okay, so that's the only exception. But we cannot send to the application something that's corrupted. Otherwise, you send a web content and you receive it differently on the other side, which doesn't make any sense. So error checking has to be done at any stage. UDP, if it doesn't do it, then it relies on the fact that the application will do it. Okay. So this is reliability and error checking. Flow control, we talked about it before. We said that flow control is the fact that we control the flow of the water that is going through to the receiver. So from the sender, we control it from the sender side. We say that, okay, so we'll send the first segment and then we'll have to wait for some time. And we'll send the second segment. Because if we send everything all at once, chances are the receiver on the other side will not be able to receive. Even if the network can send what I'm actually transmitting, maybe the receiver will not be able to cope with the traffic that's that I'm sending. So I have to do some flow control. And flow control, sometimes it's tricky because